Okay, for this video we're going to just check our answer from the previous video and make sure that our shear force and bending moment diagrams agree with what we came up with in that last video. We're going to do the point load first, and then we're going to have a look at what the UDL looks like as well. And then we're going to use this program to do solutions for standard beam arrangements, which I'll put on the board, just so you can remember what the patterns look like, because they will quite often ask you, they'll show you a beam with the UDLs and point loads on it, with the cantilever sections maybe, and normally supported sections, and they'll ask you to draw the graph. So you need to, or maybe even ask you to pick the correct one. Okay, so you need to know how to do this stuff. So, and I just had to go back in and actually log back in again, because it'll only give you a certain number of free solves on the free web-based version of this unless you log in. So let's add a beam. Let's make it 2.5 meters long, because that's the wing that we were dealing with. Let's add a support. It's a fixed support. It's on the left and it's at 0. So we've done that, and then we said that our force is at the center, and it was 10 kilonewtons, and it was at 1.25. So it was at the center, and it was 10 kilonewtons, and we go at it. Yeah, so we want to go pointing up. Okay, so that's our wing loaded up as it was. If we want to know what the actual diagram looks like, we need to solve this. So what we need to do now is we need to solve. Let's see what we get. Shear force. Now remember, if we followed the force down from the reaction at the wall, we get the negative. So that looks correct. And our diagram here goes up and then straight down to 0. So it starts at 12.5, because we said that we worked out the area underneath here. It was 10 times 1.25 gives us 12.5. And we said that it would be a positive value because it's a smiley beam. So that is 100% correct as per our solution that we did on the board. Let's have a go at doing a new diagram. So let's go back to beam. How do we get rid of these? Click, click. Okay, and this time what we're going to do is we're going to do exactly the same. We didn't need to get rid of that support. We're going to do exactly the same thing, but we're going to do a UDL on the bottom. Okay, so we look for at a distributed load. We're going to be coming up from the bottom. We start at 0, we go to the end position, and we said it was 4 kilonewtons per meter. Add it. So you can see here, that's how they do a UDL for this program. They have the green and an arrow either side. Okay, so that's like their version of the little speed humps. Okay, so now what we can do is we can try and solve this and see what it looks like. So shear force is negative once again, so we've just followed the force down at the wall, the reaction down, but instead of coming straight across like we do for a point load until we get to the halfway and then come back up, what they've done is they've just followed it all the way down to 2.5. Okay, so it slowly gets less and less, because eventually when you've got no distance between the two force vectors, you have no shear force. Okay, so that's what the shear force looks like. And our bending moment diagram starts at 12.5 and then it goes all the way down till it hits 0 at the end of the beam. Okay, and you can see it's not a straight line, it's got this curve in it. So that is how you can see too that it's positive, because it's still a positive load even though it's a UDL. But that curve is a dead giveaway that this is if you're looking at bending moments, if you have that curve, you know you're dealing with a uniform distributed load, or certainly not a point load. Okay, point loads will be straight lines. Okay, so that is how you use this program. I am going to get you to do a series of different beams that I draw up on the board, and you're going to use this program. And maybe what you might want to do is try and guess what the shear force and bending moment diagrams will look like, and then actually check to see if you are correct in your assumption. Anyway, enjoy playing with this program. It's a lot of fun.